Well, I hope people have had time to get onto this. I think we probably should make a start now. So can I welcome you all to this first in what I hope will be a series of events for the alumni. Tim, if you can stop screen sharing, thank you. Hello everyone, I'm Athena Donald, I'm the master, if you haven't literally seen me before. This is something of an experiment. Tim and I are novices at using this technology, so we will hope this works smoothly. There will be further details of other talks and events on the alumni website, or you can find out more from the alumni office. It's probably worth saying today it's a lovely sunny day in Cambridge. Slowly the college is filling up. I've been living here in the Master's Lodge all through the lockdown, and it's been a very desolate college really, but slowly the students are coming back, and we are really looking forward to having a full college, if not normality. I don't think this is going to be normality for a very long time, but it'll be good to have students back on site. It's great to be able to introduce Tim, who has been extremely active during the pandemic. Well, he always is active, but he's certainly been very visible, doing many great things, which he will tell you about in his talk. Before he gets into his stride, let me just say a little bit about his biography. Tim heads up the Institute for Manufacturing. He's been head since 2017. His other title, if you like, is as the inaugural Dr. John C. Taylor Professor of Innovation, and he is, of course, a fellow in this college. He has done a huge amount in, not just in research, but also in engagement activities and teaching, looking at the links between manufacturing, innovation, and skills, and we'll hear more about that shortly. He is involved in many external activities, which I won't embarrass him by reading out this long list. He's got a fantastic reputation as a teacher. He's won one of the University of Cambridge's Pilkington Prizes for teaching, and also a prize from the Royal Academy of Engineering. And I know he takes outreach activities very seriously across the region, and goes and talks about engineering and manufacturing amongst primary and secondary school teachers, children and their teachers. And talking to teachers is very important about engineering, because many of them won't have to clear an idea about what it is. And I am going to embarrass Tim now. I'm going to tell a story about Tim. He came to see me about, yes, I'm sorry, Tim. He came to see me a year or two back to tell me about all his outreach work, which was just fantastic. It was lovely to hear about it all. And at the end of it all, he said, did I think he was doing enough? And I was thinking, my goodness me, he's far beyond the call of duty. He's doing amazing work. And I was just so impressed. And I'm sure we will see his gifts in talking about this work shortly. Before I pass over to him, there's just one other thing. He's going to talk for about 35 minutes. And at the end of that, there will be time for Q&A. If you want to ask a question, because we can't see you, you can't wave your hand or anything, please use the Q&A function on your dashboard. Type the answers, type the questions in. If you type the answers, that will be good too, but type the questions in and I will read them out. I think that's the only way we are able to do that. So Tim, over to you.
Athene, thank you very much. About being able to give a talk, but I have to use this technology, which is not my forte. So I'm going to press a button now and hopefully all will go well. So just bear with me for a second, the screen will go dark. Right, can you now see my screen, Athene? Great. I will now assume that everybody can see it unless I get a phone message or Athene comes back online to say it's all gone wrong. So thank you very much for those kind introductory words. I guess the key bit I would just modify slightly is it's not me being busy, it's having a fantastic team of extraordinary people across so many walks of life who've been doing this work, and all I'm doing is summarising what they've been up to. and some of the mechanisms that have been put in place to support them. So I'm now going to hopefully advance a slide here and just give you a quick overview of what I'll try and do in the next sort of half hour-ish, if that's okay. So I think it might be quite useful just to go back and remind ourselves of the context for what we're talking about here, which is the COVID crisis, which of course is not over. But I think it's also, we're now in a rather different position to the one we were at back in February, March. And I need to remind myself how terrifying that period was, when we really did not know what was going on. And there wasn't at all clear what was going to be happening in the near future and how long this would last. Well, perhaps we still don't know. I should also point out that what I'm talking about here is not the all engineering responses to COVID. There's some great work being done by the Royal Academy of Engineering and collecting all the fantastic work done by engineers across the country and internationally. I'm not talking about that. I'm not even talking about work done across the whole of Cambridge and Cambridgeshire as a region. I'm not even talking about the wonderful work the university's been doing, which has been so much work going on. I'm not even talking about the great work in engineering. I'm just talking about some specific projects that were linked to the Institute for Manufacturing, just to illustrate the variety of stuff that was going on. So this is not saying this was it. This is just giving an illustration of the much, much broader portfolio of work that engineers have been doing across addressing a whole series of COVID-related challenges. So I'll do the context, and then I'll just group this into three types of responses that we observed and we were trying to support. And then I'll try and do something useful, I hope, which will be to extract the lessons that could be taken from this. And then, very importantly, this is not a retrospective historical study. It's still happening, and we need to know what's happening next as well. Sorry, we need to think about how we might respond to whatever comes next. So maybe just to start off with this context, it's interesting perhaps just to jump back to these headlines and these web pages. It's terrifying to go back, but if you do, you can see these early messages coming out back in February, March and April that, you know, this isn't just something that's happening, don't want to say it, sort of far away and it's terrible, but it's not affecting us directly in this country, to something that was happening in Europe, to something that was happening very clearly across the world and to us. It became from a remote exercise in this is terrible to something that is affecting us in a very, very real sense, locally as well. We're probably all familiar with this picture that emerged a few months back, where people said, well, I don't understand it, this COVID thing, you just get some symptoms a bit like a cold, why are we worrying about this? And then this very simplistic but rather helpful picture emerged, which was saying, look, this thing has to pass through in some shape or form or be stopped dead. What we need to do is to say, if we just let it run as it is now, it will overwhelm the healthcare system. And if we put in place some protective measures, we can spread out the impact of this and we can manage it. And this picture was all over every channel of the media was showing this picture, which, although very simplistic, did kind of help get the message across. But even with this, we were seeing extraordinary headlines suddenly coming through going, this isn't just a localized problem that can be contained within certain countries or certain regions within countries. We saw these headlines coming particularly from after we'd seen the awful situation faced in China. Particularly clear, I think, the example came from what was happening in Italy and Spain and elsewhere. And some of these headlines started to make it very, very real. And then people started to go, hang on, it's not just that the healthcare system is overwhelmed. This virus can infect anybody, of course. And so then all the knock-on effects of saying, well, hang on, if we've got overwhelming number of patients coming in, but it's also going to, of course, affect the health workers. So the level of healthcare that we can provide is going to be reduced. And then there was all sorts of very practical problems going, well, hang on, even if we have enough hospital beds and the system is there's certain bits of equipment we're going to need that are very specific to this particular virus. Do we have enough of them? And the example that's often used, or two examples, one is the problem with ventilators. If the symptoms strike people particularly badly, and particularly those who are vulnerable, huge problem comes that you're going to need support with breathing, and ventilators were believed to be essential for a very, very large number of people. It turned out it wasn't quite the situation. But at the time, it was pretty clear that we did need a lot of ventilators very quickly, and we didn't have them in the UK. And then all the stories around PPE and the fact that there's, again, there'll be all sorts of investigations of this, but there was a problem balancing supply and demand of personal and protective equipment. So this slide is just trying to remind us that that context went accelerated in a very dramatic way in the UK very, very quickly. And led to some very, very real problems. So when this happened, people, of course, wanted to help. And one of the biggest lessons, without giving away the punchline at the end of this, is just having lots and lots of people who want to help when it isn't quite clear what the problem is, doesn't solve anything. We've got to think about how you identify what the real problem is that needs fixing. Anyway, more on that later. So the three types of responses that we became involved in. So again, this is just how we, as a bit of the engineering department at Cambridge, found ourselves able to try and help those who were on the front line, depending how you define the front line, as you'll see in a second. So one, there were things that were done on a local or regional basis. And I mean, speaking very, very locally, thinking about Cambridge and Cambridgeshire here. And then there were things that we were trying to do to help people nationally and internationally. And then we grouped the projects, as I said, into three types of things emerged. One were very specifically related to how local hospitals were scaling up their activities for the anticipated substantial surge in patient intakes. And again, I'll repeat my earlier point, it wasn't at all clear what the local impact of COVID would be. And so the error bars on the predictions of how bad this crisis could be were huge. And so you have to prepare for the worst case. And this then puts an enormous burden on the logistics of running a hospital or a regional healthcare system. So we'll talk about some projects there. Then there were the fact that national government was desperately trying to respond to all these challenges. And there were so many unknowns and so many things that needed doing and so many challenges that needed to be addressed. And what could we learn from elsewhere, and where were the blockages that were stopping things happening? So we'll talk a little bit about the way in which engineers were able to look at this system problem of how you link policy issues with management issues, with technology issues to address major concerns. And then, of course, as you might expect, engineers were also involved in the physical products bit. Were there things that needed to be made or things that needed to be got to address particular challenges that were being, that arose as a result of COVID? And again, I'm not going to go through mechanically every single project that we were loosely or directly involved in, but I'm just going to put up some examples and then talk through a small number of these in more detail before, as I say, going on to the lessons learned. So there were a series of projects that related to things happening at Cambridge University Hospitals Trust, and we were incredibly lucky to be invited in by the extraordinary team at Cambridge University Hospitals Trust and at Royal Papworth, who allowed us to listen to what some of their problems were. So we didn't go barreling in there saying, we're engineers, we can solve problems. It was just listen to what the challenges were and then see if we could support in some shape or form. More on that in a second. Then, as I say, there were these policy issues. So some were literally capturing experience from elsewhere and saying, other countries have faced this situation, this is what they're doing, and to make that information accessible in a form that is of use to policymakers. So not writing important but not very accessible academic papers, rather than saying, how can we get this information to the people who need it now? And then physical products, there were some that were specifically targeted at the needs of the local healthcare system, but also others that were targeted at, that had no, that could be used anywhere. And again, I'll talk about these in a little more detail, but they were, as you would expect, technologies related to ventilation and to PPE in particular. Okay, so that's the overview of the structure of the projects we were involved in some shape or form. So just picking up on each of these big boxes in turn. First of all, the hospital logistics. So I'm going to put up some smiling faces in a minute because, again, just emphasizing this point, personally, I was only very peripherally involved in this, but I thought one of my things I should be doing is capturing what was going on so that others can share this experience and learn from some of the things that went well, and also a lot of the things that didn't go quite so well. So here we have our great team who were responsible for a number of these hospital logistics projects. So up there in the top left corner, we have Professor Duncan McFarlane, who is our one of the professors here in the engineering department, who looks at industrial information. He heads up one of our labs. And he did a fantastic job in coordinating the response that the Institute for Manufacturing was able to implement with our colleagues at the NHS. So 2 NHS colleagues on the screen there as well. We, in the smartest ones there, Dr. Ewan Cameron, Director of Strategy and Transformation, and Dan Northam-Jones, who is leading on the strategy side as well. And we were really lucky. They let us in and let us listen to what the challenges being faced by Addenbrooke's in particular were. Again, having academics listening to problems is not really going to solve very much. So the guy there with the on the left with the glasses and the very smiling face, Florian Urmetzer, he's director of one of our master's programs. And he, again, did something incredibly useful, which was to help us access resources that were available. And the key resources were these 8 students you see on the screen here, who volunteered to help out, to support things that were needed. So they're all industrial engineers and all wanted to help. But again, having a problem identified, or multiple problems, and having some resource is great, but you've got to then work out what's the most effective way of using that. So the 3 colleagues along the bottom there, Ajit Parlikad, Tom Ridgman, and Jag Srai, were able to provide the structure for the thinking to make sure that the problems that needed addressing could be addressed, drawing on academic knowledge, but deployed in the most useful and relevant and quickest way as possible. So now I'm just going to pick on 3 of the projects that were done variously by Kaya and Nisha and David and Carl and all the rest. Again, I've just picked a few here to illustrate the point. So one was around the oxygen system. So one of the interesting things that occurred throughout, is still occurring throughout this COVID situation, is we're learning new ways to treat patients with COVID. And that's fantastic. So things change very fast. So in the early days, it was, if somebody is struck down very badly, infection kicks in and then they can't breathe, then you put them on a ventilator. But evidence coming in from Wuhan and from North Italy show that actually if you put people onto CPAP, so the positive pressure masks, and feed them oxygen that way, you reduce the need to use quite so many ventilators. However, that also creates an enormous demand on the oxygen system in hospitals. So that's the first project I'll mention briefly, and then I'll talk about the support we provided for COVID testing, and then also patient flow during the predicted, perhaps, second surge. So oxygen system, well, it was around, I think it was late March, early April, I think it was Watford General Hospital reported, and this was all in the news, that they were worried about running out of oxygen. And their system was showing that there may be a massive problem. And so, as the NHS does very effectively, if one hospital has a problem, that information is passed on to other hospitals to say, you may face the same thing, pay attention to this, this is a huge issue. So the issue here was every hospital ward, every bed pretty much will have a tap next to it where oxygen can be provided to that bed. But it's assumed that not all of the beds all the time will need oxygen, and particularly not high flow oxygen that would be needed for CPAP, and certainly not what was needed for ventilation. And so a team looked at this and said, okay, well, do we know what's going on at the moment? And again, working with the fantastic team at Cambridge University Hospitals, asking the questions of saying, what do we know? What do we not know? How can we deal with this? And then go, okay, let's ask all the really basic questions to make sure we understand exactly what's going on, go through a structured process, go to engineering root cause analysis to work out what is going on and where might there be problems, where might there be bottlenecks, and then critically making this data available to those who need it. So again, all of these bits were already there, and what the team were able to do was to provide this structured approach to identifying what the real needs of the team at Addenbrooke's were, and how this could be best responded to in a very, very timely fashion, because this was knowledge they needed very, very quickly. So again, supporting those who were already doing a brilliant job to do their job and make their job a little easier in anticipation of a much bigger demand, which thankfully so far has not yet been required. A second project was looking in the early days also at the fact they needed to quickly ramp up the testing of NHS staff. So now we're in a very different testing environment now, but they needed to be able to make sure that all the NHS workers across the hospitals were being tested. And so again, the application of the systems are there. This was about optimizing it, saying, well, if we have to increase the volume of tests going on very quickly, what can we do? What can we do to support the improvement in those processes? So again, applying some really good, solid stuff about understanding how the testing facility currently runs, where the bottlenecks are, putting in place solutions to those bottlenecks, be it reorganizing things or actually producing extra bits to support, say, in this case, automation using 3D printers to provide some of the sample holders. And then dealing with the whole booking system to make sure that when a high priority test came in, it was routed the correct way through the system, but also working out the logistics of how do you make sure that people are coming in, to the right bit of the hospital at the right time for the right test. Again, supporting those who are already doing this, but under enormous stress and in anticipation of even higher requirements in the future. So going to the third example, again, with this sort of predicted next wave, there was a sense of, it's not just about, are there going to be enough beds? It's, are there going to be enough people with the right equipment available at the right bed at the right time? And to do some really nice scenario planning here around, given different scenarios, what would the challenges be and how could they be overcome? So understanding there's going to be enormous variability. There could be a surge, but we don't know how big that surge, if it's going to happen or when it's going to happen or how big it's going to be. And then identifying for each of these scenarios where the bottlenecks might be and how they could be overcome. So those are three examples of projects that were in that top left box there around hospital logistics. There's more, and if you're interested in the details of those projects, much more interesting than hearing me talk about it, we have some of our students who will be talking through this in a couple of weeks' time, and they'll give you all the details of how these projects were run and what they did, but also what they learned from it as well. So just going on to the second area, this is around policies to, or initiatives that we could support, provide evidence to support those who are actually having to make some very, very challenging decisions about what they needed to do next. And I'll just put up two examples from this. So one was looking at, so the manufacturing sector was, as people will be very aware, very hard hit by COVID. So there's issues to do with, can manufacturing firms continue, given that they have, certainly back in March, April, May and June, limited, they couldn't get their staff into the factories. Of course, demand had dropped as well. So all of these problems around making sure that manufacturing is a key part of our economy survives. But there's also making sure that manufacturing could go on doing the critical things. Were we getting food to the right place? Were we getting the pharmaceutical and PPE supplies to the right people at the right time? And again, our national policymakers are under incredible pressure to try and make some very difficult decisions. And so what colleagues were able to do, so Owen O'Sullivan, Jennifer Castaneda and Carlos Lopez Gomez and others were able to do was to do as engineers, look at the system problem and go, what bits of the national policy system around the world can we pick out things that are being done that maybe have worked or not worked, summarize these and make them accessible in a very, very usable format so policymakers can be given the ability to make as good decisions as they can in the somewhat trying circumstances. So as that was going on, then we also had the ability to then deliver some of these findings directly to various committees. And here is Carlos Lopez Gomez talking on to one of the select committees, of course, remotely, to make sure that they could get good evidence in a timely fashion to help them make those good decisions. So again, engineers looking at this as a system problem and saying, right, what is needed by whom, when and how, let's make sure we get that information to them. in a structured and useful way. And then there was all sorts of other work going on around, hang on, given we're in lockdown, given the manufacturing sector is under all this pressure, we as engineers, how do you look at issues such as food supply? What could we be doing to make sure that if things continue in a very uncertain way, we get the basics right, that we are able to make sure that the right food is delivered at the right place at the right time, all those good things. How do we do that in conditions of lockdown? And how do we ensure that it works really well? And as we recall, there were some real interesting challenges, in particularly around March and April. So again, engineers looking at this issue of policy as a system problem and saying, okay, which bits do we need to be more effectively supporting, and who needs this information, and how can we best get it to them? Another example is colleagues there, so that's Frank, Prathiba, Leo, and Jenny from Chemical Engineering and Biotechnology, looking at this issue of there's lots of great ideas out there, there's lots of great technology that could be used to address COVID challenges, but they observed, and they did produced a nice paper on this, that actually there are some, if you can't deal with the intellectual property issues, some great technologies that could solve problems that would save lives are just not available. It's not because people don't want it to be used, but it's just too difficult because you've got to unpack all these IP agreements. So they were involved in this global initiative called the Open COVID Pledge. And they worked with colleagues at Stanford and elsewhere to come up with this idea that companies should be able to find an easy way to pledge their IP on the understanding it will be used to address COVID challenges. And that was a really, really important thing that has allowed a lot of technologies to be used that otherwise would have just got stuck in lots of wrangling over IP. That's two examples from the policy side of things. Now, I was going to show a couple of videos to illustrate some of the physical products side of things, but I'm not going to do that, partly due to my own technical incompetence, but also I'm just not quite sure it's going to work in a terribly engaging way. So what I'm going to be doing instead is just talk through 3 projects, but also make sure that the links to these videos from YouTube are made available to everybody who's on this webinar at the moment. So I'll just talk about them briefly, and then we can share these with you afterwards. So just 6 particular projects there around ventilators, around PPE, and around both the making, but also the distribution of these things. So again, this picture is not a very flattering picture of the back of Rob Glue, but here are 3 colleagues who were working on something that was really, really important. And this was when the crisis struck in full force, there was a strong desire by people all around the world to help. And one of the ways people wanted to help is by donating stuff. And what you're seeing a picture of here is the Homaton PPE donation hub. So what was happening is that a huge number of, literally millions of units of PPE were being donated to the university to say, please, we'd like this to help your local hospital. That's fantastic. We were so lucky. But if it's not able to, the right thing doesn't get to the right people at the right time, it's just going to sit in a warehouse. So what happened is colleagues sat down, and thanks to Duncan McFarlane again, but also Andy Neely for enabling this, and Rob Glue and a local startup called Redbyte, got together and said, we can just do a very, very short notice, set up a pop-up warehouse, and Homaton College donated their hall for this to allow all of this huge amount of PPE that was coming into Cambridge to be sorted, and for that to be distributed to the right bits of Addenbrooke's, Papworth, primary care across the region, all of those activities. And that proved to be quite an achievement, putting it mildly, and some great lessons from that about how do you do almost an instant warehouse in a way that's useful for what the NHS needs at the right time. Again, I'll come back to something to do with that a little later. Another nice example is one that came from work that had been started already about how can we support digital manufacturing technologies in low to middle income countries. So a lot of these sort of 3D printer type things are thought about to be really useful in places like Cambridge, where you've got lots of resources and people like messing around with 3D printers. They're actually very, very useful tools. And so there's a great story on the university website, which I'd urge you to take a look at, which I'll just give you a brief summary of here, which is there was a need for PPE in some countries in many countries around the world. And this is an example from Malawi. So again, someone had posted that there was a need to do something, and some people had worked out that there was some things that could be done. But what was really nice is the two people top right there, Lucia Corsini and James Moultrie, had been doing research on how can you deploy these technologies in countries around the world, particularly low to middle income countries. They teamed up and built on some of their existing partnerships, in this case in Malawi, to allow them to then set up local manufacturing of PPE. So taking research knowledge and deploying it very rapidly in a community with a very, very different set of needs. We also saw, again, the work of Lucia and others to say there's the fantastic role of this maker community. So in Cambridge, of course, we have this wonderful group called Cambridge Makespace, who played a fantastic role in making sure that all of those volunteers who wanted to be doing something to support the NHS were able to do so. And what Cambridge Makespace did was not only provide the guidance on how to do it, but made sure they were producing what was needed by the right people at the right time. Something I'll come back to later. And all of these activities were actually then linked up with colleagues in the US, and again, sharing this knowledge about how do you do this, how does it work? Now, the next thing I was going to show you was a video of a great project done by one of the Churchill Fellows, a guy called Ronan Daly. Unfortunately, due to my technical ineptitude, I can't show you that video, but I want to just talk through it very briefly. So this was the idea that we need more ventilators. We thought we needed more ventilators. But again, smart thinking said, but hang on, can you have more than one person using a ventilator? And there's some very crude open source designs you can get online, which just say, well, we just split it. Those are very, very simple and assume that both patients have exactly the same need at exactly the same time, which of course doesn't reflect reality at all. So what Ronan and colleagues did was they developed an active ventilator sharing technology. And this is fantastic. From readily available components, they built a clever system that allowed two completely separate patients who had very different needs to be served by one ventilator. And they did this project at incredible speed, working with colleagues at Royal Papworth. Thankfully, it was not needed. And that's great that it's not needed. But the lessons learned from that actually mean that the design has been made open source. It's available to others who may need it in more extreme circumstances. So there's three projects there. There is the logistics to make sure products get to the right people at the right time. There's the making of the right things for the right place, and the designing of the right thing for the right place at the right time. And we did all this, and we were then very pleased and surprised that we got this announcement a little while ago, that the Royal Academy of Engineering gives these awards for those teams who've applied engineering in a way that's really made a difference. Now, there's 19 of these awards given to some extraordinary teams across the whole country, from the UK Ventilator Challenge through to the CPAP mask design to online platforms, all sorts of great ways engineers have delivered solutions in. And we were very pleased that we got this. And it was to everybody involved, from those who work on reception at IFM through to the learned professors who coordinated things, and everybody, the technicians, the administrators who supported this work. And we're particularly proud for that reason that we were awarded this. Okay, to wrap things up, I just want to do two more things. One is the lessons learned, and then just to let you know what the next steps have been. So lessons learned, this is going to sound really, perhaps a little bit Mickey Mouse-ish. It's dealing with something like COVID, it's a very, very complex system with lots and lots of variables and lots of difficult, weird things happening and very imperfect flows of information. So again, it's almost embarrassing to put this down here, but one of them is this basic idea that as good engineers, we should first understand. First, what's the thing we're dealing with here? Don't be so arrogant to go, I've got this clever technology, I'm sure the NHS would like it. And I'm afraid to say I did get an awful lot of phone calls during the particularly stressful period of COVID. And people just going, here's a clever thing, this would solve a problem in the NHS, I think, can you pass it on to them? Yeah, well, we can put you in touch with a clinician to see if that really is a problem, but they're quite busy at the moment. So again, this idea of understanding the problem without just being a burden on the system, well, more on that later. First, understand what the problem really is, and then co-create the solution. Next thing is that a lot of these issues, again, people were often very, very keen to push forward with a technology solution, a single point technology that would address that problem there. Whereas the truth is, dealing with something as wonderful and wonderfully complex as the NHS, it's not just we need a widget that does X. It's understanding why that particular need is not being addressed and how we can get the right thing, right place, right time. So that's, but engineers to make this work need to be thinking in terms of not just the technology, but also how's it going to be used, how's it going to be managed, and what's the policy environment within which this is operating, all the regulatory issues, all the standardization issues, all the safety issues that have to be gone through, really understanding all of those. So again, this is very simple views of very, very complex problems. The next thing was this idea that we recognized, talking to colleagues in the NHS and saying, we'll come back to the solution once we've done a bit of research and written our paper and had it rejected and then resubmitted and all of this stuff that academics have to do. No, they needed an answer very, very quickly. And they needed, and that can be a little counterintuitive, sort of countercultural for some academics, but we were delighted that the whole team that we were working with absolutely got this. It's not, I can get you something that's really good, but not for another 3 months. They needed it by tomorrow morning. And so this, slight change in culture that the perfect is enemy of the good, good enough. Solutions were needed that were good enough to solve the problem well enough now that it did what it was supposed to do, and that was great. And having this ability to be the rapid prototyping, the rapid response was critical. Another big area was the coordination, because having lots of people who were enthusiasts who wanted to help, if there isn't coordination between those who have the problems, and they may not even quite have understood what the problem is yet, other than this thing isn't working, the supply and demand issue was all over these problems. So one problem was suddenly, as you recall in the news, there isn't sufficient PPE. The government's saying, no, there's plenty of PPE. It's just a slight blockage in the system. Or is it there really isn't enough because demand has shot up so dramatically? So a whole load of issues around how do you coordinate the engineering response to avoid lots and lots of people running around in circles, generating lots of heat but no light. A related issue here was around making sure that we didn't just have bombard our NHS colleagues with lots and lots of questions. What is needed? Tell us what's going on. We had to be understanding the world they were operating in and the incredible stresses they're under and doing things in the most useful way. So for us to be able to take on a little bit of a coordination role and identify people in the NHS who also had this coordination role made a massive difference. And again, singing the praises of Ewan Cameron and Dan Northam-Jones, acting as boundary spanners, people who could see both worlds and act as an intermediary to make sure good stuff happened. The other lesson is this isn't over. And so this thought that it's a big spike and then we've managed that, what can we learn from that? It's ongoing. So I think there's a lot of lessons around agility and resilience we can take away from this. The ability to respond very, very quickly and the ability to absorb punches and be able to say, okay, that thing isn't working. How can we find a way to make it work better? Not just the NHS system, but our food system, our pharmaceutical supply system, all of those things, we're really understanding much better now, issues of resilience and how we can be more agile, right the way down to individual projects. And I'll come back to that in a second. The other bit is, I've just come in from a meeting with some colleagues from the government, is we've got to learn these lessons, and they were very messy lessons. There wasn't, we can remember with rose-tinted glasses that some things worked well and others didn't, but there's a big concern around if we just want to tell all the good news stories of the heroic things that happened, which is important that we do, we also want to talk about the things that didn't work, the things that went wrong, the things that shouldn't have happened. And they were very messy and very confused. We must learn those lessons as well. And so the next time we're trying this, if we just remember the shiny superficial bits, that's not going to be helpful at all. And so to wrap up, the next steps. Well, we're very, very pleased that, sorry for the acronyms here, but thanks to building these relationships, we're now taking forward an opportunity for some colleagues in engineering here at Cambridge with 3 of the local trusts, Cambridge University Hospitals, Papworth and Primary Care. And we now have formed a group that gets together for us as engineers to really understand the needs of, and we have representatives of the patient communities, of the nursing staff, of the allied staff, all coming together to say, these are the challenges we have faced during COVID and are still facing now and might face in the future. And so us as engineers from the Institute for Manufacturing and the Engineering Design Centre have a real sense of the customer need. So we can ensure that we're listening to what's really needed and how that can be done. The other bit we're desperate to do is to make sure that a colleague described sometimes how the University of Cambridge works. As it's survived for 800 plus years, it's clearly very good, but there's a bit of a feeling of wading through treacle sometimes. There's a lot of process, there's a lot of checks and balances, which are very good. When we had to move quickly, amazing things happened. So what are the best learnings we can take away from all these projects in terms of generic learnings about new ways of working? And finally, we as an engineering department need to be very clear that there were some lessons learned, and that should be directly feeding into our undergraduate courses and our graduate programs to make sure that this knowledge goes on to the people who are going to be most able to benefit from it, which is the next generation of engineers. And so at that point, I will just draw things to a close to say thank you very much for your attention. And happy to take any questions, but I think now I'll hand back to Athene. Thank you very much for your time and attention.
And thank you. That was a wonderful overview. Much food for thought. I've got loads of questions, but we already have a couple of questions that have come in. And can I encourage other people to type their questions into the Q&A section? But the first question comes from Michael Cohen. Are the CPAP machines that you referred to like the standard sleep apnea machines, or do they need adapting? Does pumped air help, or is oxygen specifically needed?
Now we're asking questions of a manufacturing engineer of a medical nature. I can't answer that, but I will happily put links to the information on the CPAP project that was done to answer that question correctly, rather than me waffling about it.
Okay, and the second question that's come in is from David Wallace, who's asking, have engineering techniques been applied to the issues facing test and track?
I think at this point I should claim I'm going into a tunnel and can't hear properly. However, so yes, they are, as you'd expect. And in fact, the meeting we were at earlier today was talking about some of those issues there. So clearly at the moment, things aren't going quite as well as they should, I think would be one way of describing the situation. But again, this sort of illustrates the point I was trying to make, that that's a very messy, complex system problem. For national test, track and trace. It's huge. It's got so many dimensions to it. And trying to optimize bits of it by saying, well, we'll optimize the software that's being written for this, we'll optimize the logistics of making sure the testing is happening. Again, I don't know how much I should be, no, this is all public. But if we just go for each bit there around the testing and going, have we applied good engineering principles to the whole business of testing across the whole of the United Kingdom of Great Britain and Northern Ireland? Yes. Has the system, is it working as it should do? Well, judging by the news headlines, no. So there may be that it's designed that it could do the right thing, but it can't do what's needed at the moment. And I think this is one of the problems we faced in a number of these projects, is supply and demand just don't quite get matched up. So it's clear that a system is put in place to provide a certain level of supply, and then demand is quite low. And I can speak from personal experience, having had a few COVID tests. Sometimes extraordinary overcapacity in testing, absolutely extraordinary. And now we're seeing the opposite. So now we've got to do this we've got this problem to deal with, that supply and demand keep needing to catch up with each other. So there's the actual testing bit. Then there's within testing, there's the need to automate that process. But again, coming down to some very basic things, if you want to speed up the process of what's happening right the way through getting the test kits to people who need them, either at home or in testing centres, getting those tests done correctly, getting those tests back to the labs where they can be analysed, and getting the data back to the individuals. Doesn't sound very complicated, but when you're dealing with tens, hundreds of thousands of these things at very, very high speed, it gets much more complicated. And then it sounds trivial, this little things like, if you want to take out some of the bottlenecks, perhaps one of the ways of doing that is by doing some automation. If you want to get robots to do certain things, it's much more helpful if everything is standardized. So it's nice to think that every single every tube with a swab in it is completely standard for everybody who's getting a test. That is not the case. So we have different bits of equipment hurtling around. And yes, you could optimize that using good engineering principles, but a really, really, really good way of optimizing it would be to have exactly the same thing being used. Then you can speed things up dramatically. Now, for reasons of supply of the testing kits, that at the moment is not happening. So yes, lots of good engineering principles for optimization are being applied, specifically to testing. For track and trace, I can't really comment because that's certainly above my pay grade. But I can imagine the same situation is occurring across there. But when you have physical things whizzing backwards and forwards of a very sensitive nature, where both the test kit has to be handled in a very, very particular way. It has to be used in a very particular way. It has to be got back in a very particular way. It has to be processed in a very particular way. There are many, many issues there that need to be addressed. But on the plus side, a lot of learning is taking place, and these things are getting much more efficient and much more effective. What you then do with that data, that's a whole nother thing that perhaps could be a great topic of a future webinar in this series.
Okay, well, obviously the audience is very shy because we have no further questions typed up, so I shall jump in. And one of the things, I mean, you talked about national policy, which is obviously far beyond Cambridge, but you haven't particularly said if the kind of conversations and learning processes that you've described in the local hospitals trust, you haven't mentioned whether that has itself been disseminated across the region, the country, because obviously if the fact that you have managed to build up a really good relationship locally can benefit a much wider portion of the community, that would obviously be a really helpful thing.
Absolutely. It's a really good point. And so one of the roles I think we as academics have is to make sure that this knowledge is captured. So we're not going in there just to solve a problem and then dash away again and hope that people learn from it. There is the specific action of observing, codifying, writing it up, curating it, disseminating it. And that we are doing that anyway. But the more useful thing we should be doing, or that should be happening, to answer your question directly, Athene, is that yes, so the NHS they share between trusts. And the example from Watford General Hospital, when they had the oxygen problem, it wasn't that there was a catastrophic failure, it was they went, oh, this could be an issue, right, rather than us just trying to fix it, first thing we do is tell all the other trusts, so they know that they should look for this thing as well. So that happens, I understand, quite effectively within the NHS. They already share, but it's more kind of crisis things. You need to know this. That's not the same as sharing good practice. So, around devices, that's one thing, but what we've been describing here, lots of kind of logistics, operational activities, we would like to think that those lessons could be applied elsewhere. I will say the next bit as well. There's the other bit about who's actually going to do it. So there was an extraordinary time when we had some available very enthusiastic and very capable people who could support. Right? We had those 8 master students who were absolutely fantastic and just went, yep, we can do this. If you don't have the resource, then having people in a room going, well, apparently in Cambridge they did this thing, and they go, okay, well, who's going to go around getting the data, literally wandering around getting the right data from the right people. So it's not just that this is the process you need to go through to do this, it's do you have access to the resource to do it? So we kind of would like to share also the idea that the role of universities in their local community. And I think rather than this becoming a lesson in how can we build great research collaborations, important though those are, and we want to do that, it's also about the role of universities in the regional economy and saying, okay, well, these people can come in and help and support. So it's sort of 3 answers there, I think. One is we should be documented as academics, and we should be sharing that and doing what we do in policy terms, which is to share the knowledge and make it accessible in the right form to the right people at the right time. Big chunk of work there. Then there is us making sure that we share with our NHS colleagues, so they've got it. So if they were to move roles and change trusts or whatever, that knowledge isn't lost locally. And then there's the idea that even if you know what needs doing, you still need the right resource to do it. And that's a very tricky one, because if you start talking about resource, then you talk about costings and the pressure the NHS is under already, and the level of work people have to do just to do the day job, let alone deal with COVID, let alone then deal with these new projects, is phenomenal. I've nothing but admiration for what they do. So that's the tricky bit. So it's, yes, we can document it. We want to share it and make sure it's embedded in Cambridge University, CUH and Papworth, but we also want to make sure that the resource support is there, and would encourage that to happen wherever possible with local universities.
Okay, thank you. We now have a question from Richard and Judy Cecil asking how much of the methodology work was shared internationally. I mean, you mentioned Malawi in one point, but more generally?
So we make everything available, excluding anything that's patient sensitive. We are completely open about it. So all of that work on digital manufacturing techniques for low to middle income countries, as deployed in Malawi by Lucia and James, completely public. You can get that information online. Just jumping to the non-university example, but a really, really good one, MakeSpace. They did a fantastic job of going through the standard operating procedures for making a face visor, face shield, which was incredibly valuable, because if you haven't gone through a standard operating procedure, any healthcare organization will say, well, thank you for donating these. We don't know how they were made. We don't know if they're good enough. And the point I'm making there is, one of the first things that MakeSpace did was to document this and put that online, saying all of these procedures are now available for anybody to get hold of. And yes, they are in relation to what happened in the UK, but they can be adapted for wider use. All of the work being done by the maker communities, again, very, very active open source community, putting these designs online, making them available. The challenge, of course, is putting a design online does not deliver anything. And so people can look at the design and go, oh, that's how you make one of those. Okay, how do I know I've made it right? Who do I talk to in the hospital to use it? What happens if it doesn't work? What happens if it goes wrong? So all of those learnings are much more local specific, and that's where it gets very, very tricky. So sadly, again, if I can just be uncharacteristically EO-ish for a second, fantastic to see lots of great designs out there put online open source. The tedious, boring business of making sure those designs get used in the right way at the right time by doing all the safety checks, and what happens if in a rural hospital in Zimbabwe the machine breaks, well, who's going to deal with that? So what we're trying to do is to make sure that, and as Lucia and other colleagues are doing, you look at the whole process and say, this isn't about the design of the thing, it's about the whole process. And that whole process will be different in different countries. So to answer your question, yes, we make it available internationally, but we're also very conscious that local context really matters.
And I mean, I think I do wonder how many different places are, you know, reinventing wheels locally. I'm very conscious, for instance, of actually not an engineer, a chemist who's been working with the Zafari refugee camp in Jordan, and they have just got a large UKRI grant to do PPE using locally available materials and all the rest of it. So that is a very specific context when the material they have, probably not 3D printing. But it also feeds into the next question, which has come in from Ben Brereton, who asked, how were you able to overcome the medical device regulatory hurdles in the rapid response to COVID?
So this is specifically about the ventilator issues. So there was the MHRA, the Medical Regulatory Agency, Medical Healthcare Regulatory Agency, was well aware that if we had this level of crisis, we need this many ventilators, and we have this many, the normal multi-year approval process just wouldn't work. So they issued specific authorization for what they called a rapidly manufacturable ventilator system. And they said, this is not the normal regulations, this is a special fast track one. And if you can comply with this, you can use your technology. And that was because it was national emergency, we can do this now. So it wasn't that they just said, there are now no regulations, or just said, yeah, we'll try and do everything but really quickly. It's they put in place a special kind of fast track to allow this to happen. And that has been well documented. And it's one of the things that another colleague of ours is looking at. How do you, if you can do it quickly in a crisis, so why does it take 5 years normally? And so there's this wonderful debates going on at the moment about, good point. But there's lots of reasons for that. And So to answer the question, they weren't, the government was smart. It said, we need to change the regulations to allow this to happen in a national emergency. And we're asking the question, well, if you can do it then, why can't you do it all the time?
And I think that feeds into another question. I'll just jump over one because this, I think, directly links. Comment from Hannah Wallace, who asked what legacy will be left behind by having medical devices being passed through all design and manufacturing phases scaled up much more rapidly than usual, and will it have a positive effect as devices can reach those who need them quicker, or will it just lead to safety problems? And I think to some extent you've touched on that already.
It's a great question, because and it's back to us thinking about this as a standalone crisis that will, if the mindset is it's a one-off crisis, it'll never happen again, doesn't really matter, we can just deal with legacy issues because that was a one-off. Or are we saying it is very likely there will be future crises that will need to be addressed, therefore we need to optimize these rapid processes, which is not quite the same thing as saying, well, why don't we do this for everything now? So I think it's those three bits there, and it's quite messy, but I think what's particularly exciting is that people are looking at these processes going, right, we're not saying that's how we should always operate, but there are lessons from this we should be aware of, as you say, both positively and negatively, because having lots of devices that were made super quick and got out there because they served a need, we need to think, well, what is the long-term effect of those? Sorry, the reliability of those over the longer term. Now, for ventilators, it's not an issue. They were, even though it was done very quickly, the ventilators were built to the highest standards, because as they said, no, it's not that any ventilator is better than no ventilator, just not true. You want a ventilator that absolutely works, or you don't have a ventilator.
Okay, now the last question I can see at the moment from Andrew Biller, I'm not sure that you are going to want to answer this one. It's a very important question. What kind of things can we do to help in identifying those patterns of behaviour in the workplace that genuinely involve risk and those that don't, so that workplaces can be made both productive and safe? So
if it's tricky to ask what the question means when you're not directly, is this about how do we return to work in a safe environment? Or is this, do you think, more about the lessons we've learned by working in this environment that could be applied more broadly?
I took it to mean your way of looking at processes. How can you sort of break down things that are done in the workplace? If Andrew wants to type anything further, then fine, but that was how I read it.
So the processes that we've been using if we just look at the hospital logistics projects, none of them were doing anything particularly radical. Okay, so it's not as if we came up with a new process, a new way of doing something. We just said, oh, the students picked up on this and said, look, it's a standard thing. We know how to do this. We're just executing a particular process, a mapping technique, an optimization technique, using particular software. So it's very standard stuff. The novelty was the fact that they were able to do this directly working with NHS colleagues to support what they were doing. So there was no risk in the approach we were using. These were tried and tested techniques applied and overseen by people who absolutely understood what was going on. So if that's what the question was about, there was...
Well, Andrew's come back and said, what do we know now and how do we become better informed for the future? I'm not sure that...
Yeah, no, it's a good point. I think we have, so there's I encourage people to observe the great piece of work done by the High Value Manufacture Catapult, which coordinated the UK Ventilator Challenge. Sorry, they coordinated one part of the UK Ventilator Challenge incredibly effectively. And this is exactly the question that they have, the chief executive, Dick Elsey, has been talking about, is what can we now do as a result of having done that? And the things that come up very clearly are, you know, a spirit of collaboration, that you're not trying to optimize your bit at the expense of others. You've got a common goal, it all works together. Secondly, this wonderful idea of, one of our students has just written this up, egoless behavior. We are not coming in going, right, my company needs to be the lead one here. Yes, I'll collaborate, but I want to be first. No, it's saying the project must succeed. We will all bring our own bit to it. Another thing he talked about was the pushing down of responsibility to those who have the knowledge. not those who have that position in the hierarchy. And he said that was very interesting, because suddenly realizing that people from Airbus and Rolls-Royce and Formula One teams knew stuff, and then people in the medical device companies knew stuff. And the people who needed to make the decisions were those who were doing the thing that needed to be done. It didn't have to go through lots of approvals and up to committees. They said, you know this better than anybody. That's the right thing to do. Please do it. And there's a whole series of lessons coming out generically about how we can work better as a result of having done these collaborative projects. But again, it's wonderful that we have just come from a meeting to talk about this. You go, yes, dare I say that egoless behavior and avoidance of hierarchy works very, very well in a national emergency. What happens if there isn't a national emergency? And so then we go down the debate, the route of talking about, well, you've got to, what's this analogy? It was the head of Nokia, I think, talked about the burning platform. We have a burning platform, we must react to it. But if there isn't one, you can't fake the creation of a crisis. That's not good. And so what it then leads to is the world of, say, Formula One, where effectively there's a series of relentless burning platforms. Every week they have to do something totally extraordinary to get a car to the start line and to win. So you see pockets where this happens naturally, but do we want to take Formula One behavior with all its other complementary issues and apply that across all management? I don't think so. That would probably break people. So there's a really tricky bit. There's some great lessons that can be learned. We hope we don't need a national emergency to make these good behaviors come out. What are the behaviors that can be extracted, that can be abstracted from this and used in our more day-to-day routines? And I think there is a lot around the use of digital technologies. Fantastic example was how they got engineers who'd never worked on a medical device production line, knew what to do many miles away, because they were using virtual reality and augmented reality. And in the past, people have gone, oh, that's quite cute. Yeah, well, we probably might do that one day. Why would we bother? They had to do it, and they went, oh, this is brilliant. We can now have our workforce distributed. We can have people supported to be even better at their jobs using these technologies. I think that will endure, because that was just a use case example. It wasn't essential that it was a crisis. The crisis made it really obvious that it was so important.
Well, we're past 6 o'clock, so I suspect we should wrap up. One of the lessons I hear from this as an interdisciplinary researcher is the importance of bringing different teams together and all listening. I like the idea of an egoless workforce, but I fear we may be some way from that surviving the pandemic, but let's hope. It's been a brilliant overview, Tim. Thank you so much for giving us this wonderful lecture. I hope everyone, we can't have applause, and all the rest of it, but I think that's been a really enlightening talk. So thank you very much indeed. And I can give you some applause, but I don't think anyone else can. Thank you.
Athene, thank you very much. And thank you to the audience for being here and also for those great questions. And we will make sure that the links to the videos I was going to show are made available to everybody. Thank you very much.
Thank you.